It's December, so with Christmas just around the corner, now is a great time to start building a system that'll make watering the tree a lot easier. The truth is, I've never actually had a real tree, but I wanted one this year. And once I remembered that I need to water it every day, I decided that sounded like a lot of work. So I'll just spend hours designing, testing, and building my own tree watering system. That's much easier, right? My name is Shayne, and this is my automatic Christmas tree watering system, or Actus. By the way, if you ever try to recreate what you see here, just be super careful. Don't recreate what I do exactly. I do some dangerous stuff like playing with live wires in a bucket full of water. If you're gonna do it at your own risk, and be smart. For this project, I'm gonna use a few materials. By the way, I got all this off Amazon and all the products are gonna be linked below. This is a 12 volt 300 milliamp fish tank pump, which is exactly what the wall rectifier I got puts out. I got 3 of these float switches, which are the cheapest you can find on Amazon, and that comes back to bite me a little bit, but it's what we got. This type of float switch acts very similar to a magnetic switch. There's a little magnet, neodymium, inside of this float, and this is in the off position, but there's actually 2 pieces of wire in the very end of these, or 2 contacts. Now in these contacts, they're slightly separated, but once this magnet drops to the very bottom, the magnet inside pulls these pieces closer together and starts conducting. Problem with these switches is that they're a little bit sticky. I also got this 3-foot silicone tube. It has an inner diameter of 8 millimeters and an outer of 10. That's important because that's the outer diameter of the outlet of the pump. If you want to build this, your pump may be a different size, so just keep that in mind while you're buying. The only other materials I'm using for this project are this 5mm, 3V, 20 milliamp LED. It's just something I had lying around. And then just a 1000 ohm resistor. And for the wire, I'm just using some 22 gauge wire I had left over from a previous project. This wire is 22 gauge, but you don't really need 22. You can go anywhere from 18 to probably 24, 26 even, and you'll be fine. You're dealing with relatively low current in low voltage, so you're not going to need to worry about the resistance in the wire all that much in this scenario. So here's the design. Multisim didn't quite have the components I needed, like it didn't have the fish tank pump, so in place of that is just a lamp. It just needs something 12 volt to turn on. And keep in mind, this system just has to work for now. It's going to be updated, it's going to be changed, and maybe even computerized in the future. So this is just to get off the ground because I only have a few days before this tree is really coming in. So I want this to be able to be plugged into the wall, which is in America 120 volts AC. So this wall rectifier that I have is going to put out 300 milliamps at 12 volts. That's perfect because the pump, which is that lamp, runs off of 300 milliamps. Meaning, it's roughly, it'll turn on before 300, it doesn't really matter. But that first circuit on the inside, that is going to allow the pump to turn on once the reservoir bucket is not empty and the tree stand is not full. So that's why those 2 float switches are in there. In that circuit on the outside, that's for the low indicator light. So once that float switch in the reservoir bucket reaches the bottom, it's gonna close the circuit, and it's going to turn the low level indicator light on. The resistor in there is 1000 ohms because just from playing around with it, that's what I found fit the situation the best and put out exactly 20 milliamps on that LED, allowing it to be bright but not burn out any faster than it would normally. So the circuit is out of the way, let's get to the build. I started out by laying all the wires on the desk and on the floor and connecting them all by alligator clips. Next, I put 2 buckets of water right next to each other. One had a lot of water in it, and one was empty. The one with a lot of water in it got the pump in the bottom, and then the one that was empty was supposed to be representing the tree stand. Now, before I changed the circuit, I originally had only 2 float switches, but then I found out that it wasn't going to work. I ended up needing a 3rd float switch on the first circuit with the pump. That way, when the water got low enough, it wouldn't turn on. Now in this clip, I'm just testing the system for functionality. Even though you see me do it, do not stick your hand in a bucket of water that has submerged live wires. It's pretty dangerous, especially if you're new to this stuff. And most of the problems in the testing sequence came from forgetting which way the switches needed to be oriented. I actually had to draw the arrows on the circuit diagram afterwards. It's only one of two directions, but apparently that's a lot for me to comprehend. After I was confident that my system worked to a passable level, I moved on to soldering. So I started by laying out all the wires in the correct arrangement. I took off all the alligator clips and replaced them by sections of wire that I cut out. Each section of wire was around 2 to 3 feet depending on where it needed to run. I just want to make sure I had plenty of extra in case I needed to cut off or in case I wanted to change the arrangement at some point. It's always better to have a little more wire than a little less in these situations. And then soldering, soldering, resoldering, and then more soldering. Then heat shrinking. I'm using a heat gun from a distance instead of a lighter or soldering iron to avoid heat damaging the components, especially since they're a little bit cheap and more sensitive. If you don't have a heat gun, you could always use the cooler end of a soldering iron, or you could just use a lighter. Now you'll see me electrical taping the thin wires where they have a possibility of bending and breaking. At this point, I'm building my own cardboard box. Not because I want to self-source, but because I didn't have a box. It was 11 o'clock at night, and I didn't feel like waiting for a decent-sized box to show up at my door. I then wrapped the box like a present. But this was off camera, since teaching how to wrap a gift is out of the scope of this video, and because I have zero authority to teach it based on my wrapping skills. So here's the final product. Just go ahead and take that sight in. It doesn't look man-made at all. No, just ignore the wires. Those will get cleaned up. Eventually. Probably never. So it works, mostly. Because the switches are so cheap, sometimes I need to climb underneath and tap them just in hopes that it'll reset it or disconnect the contacts. But otherwise, no, I gotta replace the switches at some point. This is ridiculous. And because of that switch problem, I had a spill that would impress BP. So after a few times I had this problem with the switches, you know, I don't learn my lesson. I overfilled the bucket and I forgot that the pump doesn't stop the water. So I ended up letting it run and stopping it once the switch didn't work and it was right at the top. So at one point I turned on the system and everything seemed to be working okay. It was filling. Problem is the switch didn't stop it. So it kept going and going and I just got to the off switch in time to where it wouldn't overflow. But this is my build. So that didn't work. The pump stopped, but I forgot the pump didn't have a valve switch sort of thing on it. It didn't have any way to stop the water. So since the water in the bucket was high enough, it acted as a siphon and kept pulling water into the tree stand, and the water at this point is pouring over the edge, but I am too stubborn to ask for help. My mother was sitting 5 feet away from me on the couch, and now I am running into the kitchen, grabbing an entire roll of paper towels, coming back, and then laying them all out under the tree, trying to soak up all the water that had just gushed out of there. And my mother was watching me struggle, but she didn't say a word. She didn't even look in my direction. I think she was trying to limit her disappointment in me this year. But when left untouched and in a working state, it works just fine. I mean, it's not really any design problem, it's just the switches. So next year I'm just gonna have to take them off and resolder new ones on, and better ones. By the way, the switches are held on the bucket by duct tape and super glue, and in the tree stand by a zip tie. You know, I think that's a problem for next year. And also when I update the system, I'm gonna need to add some sort of wire mesh or something over the tree stand, because I found my cat a couple times, you know, sticking her paw in there, and I guess she liked the taste of the sap, so I started. I don't know why she wouldn't drink it. She's got to be different. You know, I guess cats really do like the taste of sap, or mine are just a little bit off. No, mine are a little off. Now remember, this is not a pro system, nor will anything of this caliber be sold. This is something I still need to work on. I'm not too concerned about taking a ton of time to perfect it. This was more of a quick and cheap project to get the job done until I can make it better eventually, if I do. So when I rebuild this next year, I'm gonna have to make some definite changes. I pretty much just need to buy better float switches and the system should work just fine, and maybe find a way to fill the bucket above the tree stand without it siphoning in. Thank you for watching, and if you're going to do this build, just be careful, be smart, don't do what I do it better. So let me know what you think. If you're gonna build it on your own, you have the circuit diagram and you have all the things not to do. So if you build it, drop a comment, let me know how it is. Thanks for watching. See you next time.